Good morning, everybody. Just waiting to see everyone joining. I'm sure your sound is all just adjusting. So whilst I'm not saying anything important while you're doing that, so don't worry. I'll just wait till you all get online. It's 10 o'clock. Computers will be a bit slow, so getting used to Wednesday morning. I'll just let you all join in. Yeah, most people are getting on okay. So we've got a holding side up, so hopefully you should know that you're in the right place, the ESN annual marketplace. This is our dynamic containment session. Just check that you are in the right place. I can see most people are getting online all right, so just give it a bit longer and give everyone time to get on and log on. Like I say, it's Wednesday morning, 10 o'clock, all ready and raring to talk about dynamic containment, but it might take us a bit of a while to get up to speed. So I'm sure your computers all feel the same. So I'll just give you a little bit of time to get online. If you want to say hi in the chat while you're waiting for others to get on. Normally we would say where you're from and what the weather is and all that kind of stuff, but we do that all the time. So this morning I was thinking maybe you could tell us your favourite storage joke. If you have a favourite storage joke, your storage pun. I was just talking to my friend Hannah about that guy who was arrested for drinking battery acid last night, and he was charged later on. So that's the best I can do. That's the best I can do. It's 10 o'clock on a Wednesday morning, guys. Don't expect any more. But if you've got any better storage jokes than that, I mean, I know difficult to top, but if you've got any better ones than that, stick them in the chat. Or you could just say where you're from and who you are and what the weather's like, and that's also totally fine. No judgments there. Okay, right. I think we've got plenty of people clocking up there, so I will just make a start, I think, just say hello. So thanks everyone for joining. Just to check you're in the right place. This is the Electricity Storage Annual Marketplace. So this is the second day of our annual event. So we had a really great day yesterday introducing the sessions, talking about a more broad overview of where we are in the storage sector, and then a little bit about flexibility markets. So this feels like a good follow-up today to dive into some specific flexibility markets. So yeah, just to check you again, you're in the right place. This is the dynamic containment session, the electricity storage marketplace. So in case you don't know who we are the Electricity Storage Network. We're the UK voice for electricity storage. And we're managed by Regen. Regen's a not-for-profit renewable company with a broad mission to decarbonise the energy sector. So hopefully you do know who we are, but if not, you might learn a little bit about that today. And this is our annual event, so we run this every year. We've been doing that for, I think the ESN has been running for this event for over 10 years now in some form or another. I think this is probably the first time we've done it online. So thanks for sticking with us. We're using a new platform, a bit of a new medium to interact with you all. It's not as good as being in person, but hopefully we can still interact and have a good time online at least. So thanks to our sponsors this year for making this happen. Obviously, it's a bit more difficult online, so we wouldn't be able to do it without our sponsors sponsoring us this year. So thanks to Fluence, Lane Clark Peacock, Road Knight Taylor, Swan Barton, and to Schneider Electric as well, who were actually a few days ago given that accolade of the most sustainable company in the world. So great to have that credential on the ESN membership. So well done to them. Okay, so before we get into the session, just a little bit of housekeeping, seeing as we are online. So we're using this new platform, Hoover, for interaction. Pronounce it whatever way you want to, be creative. So do take a look around that platform, have a look at the app. There's loads of stuff to do on there. It's quite good fun. You can interact with all the 600 plus other people who have registered on the platform. So some of you are watching on that platform, some of you will be in Zoom. Either is absolutely fine. You get almost the same functionality, a little bit more in Hoover, so you can interact with them delicately a bit better in Hoover. But you can ask questions on this session and chat in both of those things. So don't worry, whichever platform you're using, your question will get through, and we'll try and take that on. Okay, so let's get into the bones of the session. Hopefully that's everything covered off, and you should feel pretty safe with all your tech. So today we're talking about dynamic containment. So if you don't know what dynamic containment is, then hopefully this session will help and will give you a bit of an overview of what DC is and what it does for the system. So just really broadly, it's a new frequency market for which the National Grid electricity system operator are running. And we've been pushing for a new frequency market for some time within the ESN. And so it's great to see Faye and Rich and her team start this up last year. A hell of a lot of effort has gone into that. So really great to hear from them about how that's going. And it's interesting to see that all participants but one are, I think, of DC are ESN members. So clearly this is a really important market for storage and for batteries particularly. Right now, it's really helping to advance the industry, but it also perhaps it's a really good sign of what flexibility will look like in the future, how it will be valued in years to come, maybe in a net zero world. So we're hoping to get into some of those questions today, and hopefully you'll come away with a bit of a better idea of what DC is and what it can do. So without further ado, I will introduce the speakers for today. So we've got Richard Hanson, who's a Flexibility Services Development Manager at National Grid ESO. We've got Faye Relton, who's the Ancillary Services Development Manager at ESO as well. And then two of our members, Nathan Murray, from Engineering Manager at Pivot Power, and Roger Hollies, who's the Chief Technology Officer at Arenko, both of whom have had a lot of experience in frequency markets and dynamic containment particularly. So great to hear from them and their experience of it. So we're going to hear 10 minutes or so from Rich and Faye on how they've been setting up DC, what they've been finding, how it's been going, basically, and then some reflections from Nathan and Roger before we go into some questions. So yeah, without further ado, I'll hand over to Rich and Faye for their presentation.
Lovely, thanks very much, Madeline. Hope you can all hear me. So I'm Faye Relton and I'm responsible for frequency response reform within the ESO. So as Madeline said, Rich and I are here today to talk about dynamic containment, which is our first new frequency response service. We call it DC. So I'll give you the background into how we've got here and why we need new services. And then Rich will take you through DC at a more detailed level. So if we just pop onto the next slide, please, I'll set a bit of context. So part of the ESO's role is to maintain a stable system frequency. The amount of frequency response needed is directly influenced by system inertia and the size of the largest generation or demand loss. The need is greatest when system inertia is low because frequency moves faster when inertia is lower. Along with the continued growth of renewables in the GB market, we have observed a consequential decrease in system inertia, especially at times of low demand and high renewable production. System inertia will further decrease as we move towards our zero carbon 2025 ambition. As a result, a key priority in our frequency roadmap is the development of new, faster acting frequency response services to support our operational needs. So we need response that acts faster than the products that we use today. With lower inertia on the system, the frequency moves more quickly. So that's why we need faster acting ones. The certainty of the need is also less because of the variable factors such as transmission demands and output from wind and solar. This means we need a market structure that allows procurement and access to flexibility closer to real time and as needs become more certain. The alternative would be to procure greater volumes of the existing response products that we have in place. So whilst this would have the same effect in the short term, it's unlikely to be a sustainable or economic approach. So we decided to introduce 3 new services: dynamic containment, DC, dynamic moderation, DM, and dynamic regulation, DR. And we began industry engagement on these services back in 2018. And then since then, we produced a frequency response and reserve roadmap, setting out our intentions. So whilst the pandemic last year slowed our progress down, some of our teams focused on the low levels of demand and worked on the ODFM service. We were all pulled back together quickly in the summer, and we were really, really proud to launch the first new response service, DC, on the 1st of October. So Rich will talk to you in a lot more detail about dynamic containment. I've got a little diagram on the screen showing our intentions in terms of timelines, and I'm sure there'll be conversation a little bit later on about DM and DR when they come in, when we transition out of the existing products. I'm happy to talk about that. Before I pass over to Rich, I just wanted to, as you can see on there, we will be engaging later this year with DM and DR with industry, and I'm really looking forward to kind of coming back out and speaking to you all. It feels like I've gone a bit quiet in the past few months. We've been looking at how we automate the processes that we've put in place. We introduced day-ahead procurement, daily procurement with DC, which is the first for us, and we were really proud, really excited to do it. We did it quickly. There's a lot for us to learn. There's a lot for us to improve. So I've been looking at the automation, but it is a significant development in our market reform activities in procuring daily, and that's under role 2 in our forward plan. And if anyone wants to know a bit more about that, happy to take questions or contact me separately, and I can show you the documents that you can read. So without further ado, Rich, if you want to go into the more detailed bits of DC. Thanks very much.
Yeah, fab. Morning, everybody. So obviously, as Faye was saying, dynamic containment we launched in quite short timescales. So a big element of that was to work out how we ensured that we carried on developing and improving and moving the service forward. So you may have heard a lot of soft launch kind of being thrown around. So we've adopted a soft launch approach for dynamic containment, which kind of really places some focus and future drive to making sure that we continue to improve this product. So I think everyone recognises that with the speed in which we put this in, there are going to be future developments and improvements as we go through that. And we're really excited to be engaging with industry on that to make sure that kind of we can do that in a collaborative way. So just having a quick look at what kind of we've done to date. So as Faye said, we went live on the 1st of October with our first tender at day ahead. Throughout November and December, we had a lot of kind of engagement with industry, meeting various forums, holding one-to-one sessions with those that were delivering the service. And that allowed us to get a really kind of early insight into what was working, what people were finding difficult, and areas that we might want to target for further improvement. So out the back of that insight period, we pulled together our soft launch development document, and the purpose of that is to identify all the areas that we want to continue to look at and improve and develop in the service, and we've categorized those into 2 waves, which I'll come into shortly. Out the back of the early insights period, we launched an EBGL consultation on the service, aligned with, we've also gone out for a consultation for our short-term operating reserve service, if people are aware of that. And really that was to take advantage of any early developments and kind of quick wins that we could make to the service to really start to improve and mould that service towards its enduring state. So those consultation responses closed last week, and we're hoping to get our final responses and proposals over to Ofgem in the next coming weeks. So we should hopefully see some early developments in the DC service coming over the next couple of months, which will be great. And also today is a big deadline for big milestone for DC. So we went live with our BM stacking. So for those units that are providing dynamic containment and are also balancing mechanism units, we've unlocked the ability for those units to stack receiving instructions from the control room whilst contracted for DC. So there's revenue stacking, additional flexibility. We all recognise those things are really important, and this is the first step towards doing that. So I think I got a nudge from the control room about 10 minutes ago saying that they'd sent some of those first instructions. No doubt Roger will talk to you more about that shortly. If you can just go to the next slide. So yeah, so our wave 1 work under the soft launch. So the wave 1 work for us was very much about embedding the service. So this is the fastest frequency product in the world, I think. There's huge amounts of data that we're getting from providers on a 20 hertz granularity. It's new contract terms, new ways of tendering. There's a whole host of learning and embedding and really kind of stabilizing ourselves to set ourselves up for kind of more detailed and complex enhancements, should we say. So a lot of the Wave 1 work has been underway since day one, and will continue through towards towards the end of this financial year. And we're really excited around some of those developments. So some of those things you'll see we've already made good headway on, such as the BM BOA stacking, the EVGL consultation, industry engagement, and really it's about kind of getting that very solid foundation for us to build the service. If you could just go to the next slide, thank you. And then Wave 2, so this is a lot of the work that a lot of our kind of forums and participants are really interested to see move forward and progress. So it's some of the more complex and challenging areas to address, but will really open and unlock a lot of the additional kind of volume in the market and new ways of doing things. So things like our baselining, aggregation, metering, all of these topics that are quite complex and challenging, but we really want to sit down and spend the time with industry to work through those and see what we can make work for both parties. And in that second wave will also come the HF element of the product. So at the moment, we're only procuring the low side of dynamic containment. We're hoping to kick that work off in April. So sort of towards the end of March, we should be sharing further plans in terms of what order we'll be looking to kick those pieces of work off. Next slide, please. So DC, I'm not sure how much people know about DC for those that are on the call today, but we currently have just shy of 400 megawatts of capacity registered at the service, and the current price is hovering around the £17 per megawatt per hour mark, and we're only currently procuring for full 24-hour contracts. This gives the market an indication of the type of volumes we'll be looking to procure over the next year, kind of month by month. You can see that some of those volumes are fairly sizable as we move towards the summer months. So getting up to 1400 megawatts, that's, it's a huge amount of a new service. And we're really looking forward to growing this market with industry and kind of engaging and seeing what we can do to support bringing on new volume and things. So clearly there's a long way for us to go from the 400 megawatts that we're at today to get up to that 1400. And we think that a lot of the wave 1 and 2 work will help bring that volume on. We have had a lot of questions around kind of procurement and tendering and things like that. So we've been very clear since day one that our ambition, whilst today it is manual tendering, we are really looking to kind of bring in enhanced automation there. We've run the EPEX auction innovation project, which has given us some great learnings for going forward. And no doubt we will be looking to introduce an auction platform to enable us to unlock enhanced granularity of procurement, which should really open up even more access to megawatts and things. So that gives a bit of a flavour as to kind of, I guess, what DC is, what we've done to date, and what's coming up. I guess back to you now in terms of moving on.
Brilliant, thanks Rich and Faye. That's a really good overview of where we are with DC right now. Dynamic containment, sorry, I'll try and expand on some acronyms if we can. I think BM BOA was a pretty good one, but if we can expand on some acronyms, that would be good, but I appreciate it's very hard when we're talking about all these technical things. I just an initial question to ease us in, because there's lots of more techie questions to come, but I think I'm really interested in what you've what you've been talking about today, but also in speaking to you both over the last few months of seeing this service develop. And Faye particularly, this has been, I've heard you say this is such a new product and a big step up for the ESO. I just wondered if you had any personal reflections on why this is such a different service, what it is about it that makes it so different and positive, but also challenging for the ESO for your team.
Yeah, so
after you, Faye.
Thanks. I imagine Rich and I have got different reflections actually. Mine are more around the procurement side and that's because it's selfishly, that's what I'm focusing on at the moment. We're procuring daily. I mean, the closest to real time procurement previous to that was our weekly auction, which is still going, and it's running up until the end of November this year. So we are seeing an increase in data, in the volume of data every day. So we're having to change how we work. We've, as Rich mentioned earlier, we have got manual processes at the moment. Personally, I work Boxing Day. My boss worked Christmas Day. So we've, you know, to review and approve the tenders. So we really want to change that. Everybody's going to have to work weekends with this weekend working, and the more we can automate it, the better it is for the ESO and for providers. So I was so proud, absolutely thrilled that we delivered it in October, especially as actually we managed to get the project team together in July, and it was a really quick turnaround, including an EBGL calendar month consultation. So feelings of pride, but also really, really itchy feet about manual processes, and I'm desperate to get the procurement processes automated, which is what I'm working on at the moment. And I'm really excited to, hopefully then that means that we can have more clever procurement processes, so similar to the weekly auction trial, and that's what I'm exploring at the moment. So excited, proud, anxious, keen to get moving.
A roller coaster by the sounds
it really
of it.
is. Yeah, it really is.
Yeah,
so
that's great, and we've really appreciated your engagement with us as the ESN throughout that as well. Despite all of that really hard work you've been putting in, you've still been spending the time to talk to us in the industry, so we really appreciate that. Richard, anything from you that you wanted to add on that?
No, I think I'd echo what Faye was saying, you know, especially around timescales. So, you know, the teams in the summer did an amazing job introducing and putting in the ODFM service under really, really challenging conditions, and then almost straight out the back of that, the team kind of stepped up again, and we've managed to put kind of the fastest acting frequency product in the world, possibly, in place, you know, in a really short time. And I think whilst we recognise there's still a lot to do, and there's some, you know, some target areas to go at, the old kind of more traditional FFR services, you know, they haven't changed for probably 10, 15 years really in kind of any major changes. And this has really given us the opportunity to, you know, pull together all the things we want to do and develop, and it's kind of that first look as to where, you know, we're getting huge amounts of performance data, which is fantastic. We're getting real-time metering for these units, you know, we're using APIs, and it's just moving forward really, and it's kind of the world we want to be in, which is really good and exciting for us as a team. Yeah,
great. It's nice to hear you say so much of world firsts, and the first to do this, and the next step for us in the industry in the UK is the first to do that, and it's really nice. I think
it is anyway.
Well, let's say it is. There's only a few hundred people listening. We'll claim that. That's fine. Yeah, so it's really nice to hear. I think we'll dig into a lot more of that over the next half an hour or so, as to, you know, why this is such a step forward for the industry. So plenty of other questions for you too, but I'll come to Nathan now. So Nathan Murray from Pivot Power. If you could just introduce yourself again, Nathan, and Nathan's going to give us a few reflections on how he's found dynamic containment from his side.
Oh, fantastic. And good morning, everyone. My name is Nathan Murray. I'm an engineering manager with Pivot Power. I'm a technical lead on developing new projects and helping ensure that, you know, our new storage assets that we're developing at Pivot Power comply with the application requirements, one of which dynamic containment. So really excited to join you today. I'm with EDF now. Pivot Power is an EDF company, and EDF, well known to some of the people on the call, has a long history, particularly in France and in nuclear, but EDF also has a very large renewables arm, which is one of the largest UK investors in renewables, with 1 gigawatt of renewable generation operating. And Pivot Power, that I'm part of, is the flexibility arm of EDF Renewables. And we have projects where we work with lithium-ion batteries, flow batteries, and even EV charging networks. So we have a sort of a broad flexibility experience that we hope we can bring. And together with EDF, there's a strategic goal within our business to be the leading developer of energy storage in Europe, with a plan to develop 10 gigawatts by 2035. But on the EDF plate, we have one asset behind the meter at Arsenal Stadium. EDF Renewables has a 49 megawatt asset, mostly operating in the EFR market. And we have 100 megawatts into construction right now, coming online within the next quarter. 2 gigawatts in the pipeline. So lots of exciting stuff. We're really excited about it. So to get into the details about our thoughts on dynamic containment, how does it help us achieve net zero? Why is it important? I mean, clearly, you talk about adding renewables to the system. There's this interaction with inertia, and if you look at the DC requirements table that Richard brought up earlier, if you were to squint, you almost could see a solar radiation table. Maybe there's an interaction between solar energy coming on in the summer and requirements for dynamic containment becoming more necessary. And certainly in some variants of a high renewable system, you might see lower inertia on the system. And inertia is important because it helps stabilize the system, particularly in a system that is slow to respond. And that's kind of the key about dynamic containment, is it's making the system smarter and faster to respond and to enable a lower inertia grid. Certainly there's other products that National Grid are thinking about to bring more inertia onto the system. We kind of see dynamic containment as a tool for them to use if inertia is lower and you need to be quicker to respond. So certainly the requirements of DC are quicker than FFR. The assets need to react faster than you can say dispatch. And I would speculate that we really need to enable the control of grids with lower values of inertia without paying generators to spin idly, which kind of seems from a physics point of view a bit wasteful. We're a bit biased. We're developing batteries. So there certainly has been some talk about generators needing to upgrade the control systems to comply with these requirements of DC. In the spirit of net zero, I think it's a great thing because it does enable this low inertia control. But some feedback we could have is we would like to see clear feedback and performance targets for us to be hitting. It could take 2 years for us to develop a new asset, but the ESO is being nimble, innovative, quick, and we highly respect that. So, in another few thoughts about dynamic containment, it's an interesting product. As I anticipated before, it's about speed, but it's not just about speed or power. It's about control, because we anticipate when we're building our new assets over the coming years, we might actually be needing to detune our assets. Actually, our assets are a little bit faster than what the dynamic containment wants us to provide. So we need to actually have a delay when we see a response, and then we can actually have to ramp up our assets, not too quickly and not too slowly. And that control is the value that we think we can bring to the grid. So we're looking forward to the discussions later today, and I guess on to Roger for his thoughts.
Great, thanks, Nathan. I think we've all been waiting for Roger to come in and cheer with to say that his stacking has gone live. I think it's the storage equivalent of Arsenal scoring in the 90th minute. So disappointed that we didn't have Roger interrupt with a big cheer, but maybe he can do that now in his 5-minute reflections. Over to you, Roger.
Yeah, I'll maybe finish on that one. Good morning, everybody. Thanks a lot, Madeline and the team, for inviting us and setting up this fantastic conference. It seems to be going really, really well, although I haven't had a lot of time to look at it because we've been pretty busy getting stuff ready for today. So my name's Roger Hollies. I'm the CTO at Arenko. We are a technology provider. We develop software and hardware solutions to automate and optimize flexible assets, so such as batteries into energy markets. So we kind of use a stack of cloud-based software, data science, machine learning teams, and then on-site hardware, what some people like to call edge computing, to basically create a vertically integrated control and platform for customers to basically use to maximize revenue from the systems. Dynamic containment, it's been a fantastic ride for the past kind of 2 or 3 months. We were in from day one with our asset. We were one of the first 2 providers to be in from day one. And we've not dropped out of the system now for nearly 3 months, until just last week when the intraday markets went absolutely bonkers. And despite the £17 per megawatt per hour price, to be doing day ahead trading, was more profitable. So we dropped out. But it's been a really interesting period. We've brought a second asset on into DC at the beginning of this year. And thanks to the processes that the ESO have set up, they've really streamlined this. We were able to go from being on site at the beginning of January to being in the service, delivering the service, generating revenues for our customers within 2 weeks. So that includes hardware installation, commissioning, registration, documentation, testing, the infamous DC testing, getting through all that, getting that processed by grid, and then giving us the green light, bidding in and winning a contract. So it's been an extremely exciting period. So why is DC a stepping stone for low carbon or zero carbon future? So I've got kind of two personal targets that over the next few years. One is to have 1.21 gigawatts of low carbon flexible power on our platform, so I can power a flux capacitor and go back to 1988. It terrifies me that some people might be too young to get that reference. And DC is facilitating that. We've seen a huge amount of interest from industry, investment, looking at energy storage, and it's being driven by this market and the other markets they've developed over the last 6 months and these great targets they've put in place. Which leads me to my second kind of target, which is I want to be part of this zero carbon future. And I think a lot of very clever and very motivated people in the industry do. 2050 is a long way away, but the ESO target of a zero carbon capable system by 2025 is so exciting. To think that we might be able to claim in the next 4 or 5 years that we've operated the UK grid with at a zero carbon, maybe for 2 hours, 1 hour, even just half an hour, to be able to be all charging towards that as a target, I think is so exciting, and the challenges that it puts up. DC and other fast acting services like it are critical to hitting that target and to be able to operate in this low inertia system that people have talked about. Like I said, it's really, really exciting and it's possible. I think two things. One, DC is very challenging service, very challenging testing environment, but the way the ESO have gone about it to pull it in has been fantastic. It's been a really learning by doing approach, which I don't think is it's not the traditional DNA of National Grid and the ESO, but I think they're showing incredible flexibility and engagement with industry to get this done. And, you know, like I said, the industry is full of very good companies, very clever companies who are gunning to solve the problems that are going to be put in front of them as part of this roadmap. And dynamic containment as kind of the first foray into that, I think, has been pretty successful. But it's also, and Nathan alluded to this, we're just scratching the surface of the capability of these systems. So inverter driven technology, power control, electronic power control systems, inverters at the front of, and in our case, batteries. These systems, we are just touching them. We've had to put a delay, power delay of 200 to 300 milliseconds. So over a quarter of a second delay on the power response in order to get these tests. So yes, this is one of the fastest services, frequency response services, but these batteries have got a lot more to give, and that's not even tuned. That's using the pretty standard control systems that are installed. They can go faster. You can talk in, you know, two or three cycle response rates, which means that there's going to be a real nice balance between real inertia and moving to digital inertia, I believe, in the future. And I'm not even talking about reactive power, which can be delivered completely independently of active power to provide voltage support. And then you've got hybridization with other technologies, potentially with flywheels, with solar, with wind. All of these things, industry, all industry needs is clear definition of the problem, and industry will flood in with solutions for it. And I think this is a really good demonstration of how the ESO can work with industry on it. So it's a really, really exciting period. Arenko are absolutely stoked to be involved and to be on the front line of much of this. And as somebody has been mentioned, today we've gone live with dynamic containment stacking with the BM. So that is providing the low frequency dynamic containment when the frequency goes low, pouring power into the system to respond. But at the same time, we're offering our charge capability to the control desk. So the control desk now see our assets with charge power available. And we had a nice, I think, my phone just buzzed, and we got a nice, what was it? Yeah, 7 minutes, a 7-minute instruction was it, at where they've paid us to charge the battery. And that is charging that we would have to do anyway, but we would probably just do it on the imbalance market or the day ahead or the intraday and just find the best price. But instead of doing that, we've actually offered it up as a service to Grid and Grid to the ESO, and they've put in this stacking capability. And this is the key thing with getting towards zero carbon, is being able to stack all of these services together. It's such an exciting time and an exciting industry to be in. And I think, Faye, I think you're quite right to be proud of this, of how it's gone. It's not gone perfectly, but that's where we are. That's what you have to do in order to innovate and to move quickly. We've got some big targets ahead, and I'm really excited to be involved moving forward, as I know the rest of the team are.
Amazing. Thanks, Roger. Some really, really positive thoughts there. And it's really, really nice for me to hear as well that this service is really making the most of storage and batteries and what they can provide. It's really, and it's nice to hear that we're actually at the start of that. You get so immersed in storage and batteries and all the other technologies and what they can do for net zero that you kind of think, right, we're there, we're doing it now. Actually, we're just at the cusp of that. We're starting. There's so much more exciting stuff that we'll be seeing happening, and it's nice to hear that there's more to come. So that's all very positive. I think we'll just take a little bit of a step back, because I think there's a level of a very big range of knowledge on this call. So I think it's probably worth just saying there's some good questions coming through about, why do we need such fast response? I think it's quite interesting to maybe reflect back on the firm frequency and enhanced frequency response markets that we've had in the past. And maybe, Rich, perhaps you could just give us a bit of an idea of how why this is different from the frequency response markets we've had before, and why they do need to be so fast. What's the advantage of responding in such a fast time? And what does fast mean, actually? It'd be good to know. I think some people might think fast is a few seconds or a few minutes, but actually it's much, much quicker than that. I'd be interested to get your thoughts on that.
Yeah, so if you look at the traditional kind of FFR market, response times are sort of 10 minutes to half an hour in terms of delivery times. They were put into place kind of well before I was at National Grid, and they were looking to solve a very different problem. Probably back then there was a lot of big traditional power stations on the system. Inertia was very high. Stability was very, very high, and as we're moving to this new world, levels of inertia are reducing. The rate of change of frequency is much higher, and that's really the purpose behind DC. Is to catch those. Is to catch the frequency. The frequency is moving a lot faster and more often, and really that's the need for that service to move very quickly to catch that frequency and stop it moving at such a rapid pace. So yeah, fast. Yeah, depending on what type of asset owners you're speaking to and which world you're working in, fast can mean many different things. I'm sure when ESO say we're being fast in moving services, some companies may say, well, that's a snail's pace for us. But it is that shift. There's a lot of work going into these things and making sure that we can kind of work in a learning by doing way and moving those things forward. But yeah, fast in this sense is kind of all of this is happening in under a second. To give you kind of an idea of timescales, and as Roger said, that the art in a lot of this is controlling the asset to deliver the service that we're looking for. So just because assets can deliver incredibly quickly, that we've set out the parameters for which we need as a system operator for our service to act upon, and being able to control assets and have that level of complexity is really beneficial to us, because then we know that these huge volumes of DC, you're talking over 1,000 megawatts, are all acting in a uniform way within a set kind of range and window. That gives us the assurance that the service is going to work and move the system the way in which we need it to. So yeah, it is different to the traditional products, but we are moving into a new world, and these products kind of have to look into the future as well. The problems that we're trying to solve in 5 years' time, we need to establish these markets, grow them, fine tune them, develop them.
Yeah.
Can I chip in on that as to why speed's important? So this service requires an initial response within 250 and now 200 milliseconds, and then full response within a second. And the reason why fast is important is I like to think of the grid. One of my metaphors I use is it's like a marble statue. When it's falling over, if you catch it early, you don't need a lot of power to keep it upright. But if it falls over a lot, the later you leave it, the harder it is to push it back. So the more volume of power. So the faster response, and this has been proven by a few studies by some of the big universities, is the quicker that you respond, the earlier you catch it and the stabilization comes in. And so, you know, the ESO are putting in, obviously they'd probably want as quick as possible, but there are issues with going too quickly. That's why there's a delay in the response initially. But I think as we move forward, we're going to see that getting tighter and tighter and faster and faster. And then in a low inertia system, which is then the marble statue is actually quite light and is kind of flipping around. But the actual the inertia systems that are around that are quick enough to hold it and keep it balanced and stop it falling over.
That's a really nice analogy. I might use that one. Steal that one. I was making notes there, so credit to me if that one comes back up again. I just want to reflect a bit on what Roger and Rich have been saying about the need for fast response, but also a lot of control. And Nathan, you touched on this as well. And I think this is a really interesting shift for me as well, someone who has a background in data and data science. The shift for storage and for batteries in particular, of the amount of data that you get, the amount of data you need to control it, the speeds of automation that you need to be able to control these assets, I think is a massive shift. It's a different world to the the incumbent thermal generation. This is a completely different world. And Nathan, I just wonder if you had any reflections on for DC, but also more generally, what does that mean for you as someone operating assets? How is that challenge? Is it a challenge, and how do you deal with it?
I'm not sure it is challenging, because I think sort of the way we've been asked to respond is almost pretty straightforward, right? You see the frequency change. It is in a post-fault situation, potentially. You know how long you have to start responding. And I think your ramp rate is pretty constant. So you just start responding along the pre-programmed route. It's not like we need to do any complicated, we know if it's here, we have to respond faster to catch it. So we're really, I think Grid has tendered for the services. They found a method they think is going to reduce system costs, which is really important for net zero, and we're responding to the challenge.
Yeah, it'd be interesting. We have a session at 11:30 with Rob Rome from the interim head of national control, talking about what happens in the control room. And of course, this level of this speed and level of automation is obviously a challenge for them as well. Faye, you talked about automation and the fact that this is manual right now. What sort of things do you need to do as the ESO to get to that automation? What challenges are there for you guys on the other side of dealing with that?
So we run manual tenders at the moment. It's not an auction, really. So we'd like to use the approach that we've taken in the EPEX weekly frequency response auction trial, which is the pay as clear auction. We've had some fantastic feedback from participants on that as well. We've got a lot of systems in National Grid ESO and critical national infrastructure. We've got quite a lot of serious systems, and you can't just bolt things on as much as I'd like to. So what I've done is I've been working with IT, and I'm trying to work out how we can compartmentalise procurement, focus on that first. We've proved we can do it with the weekly auction. Let's try it again, but make it daily. So one challenge is getting that in place. And if any of you have read our Rio business documentation and our forward plan, we talk about how we want to bring in a single market platform, which massively improves user experience externally and internally. And we also want to have an enduring auction platform. We don't have that yet, and we don't want to rush it. We want to do it properly with the right engagement, the right tenders to go out and give suppliers the opportunity. So how do we bridge that gap in the interim is what I'm working on. And I can't really say much yet because I haven't gone through all the commercials, but I'm exploring a procurement option that bridges that gap. That means that we can go kind of introduce these pay as clear auctions as we've been doing with the weekly auction trial. The other aspects of the end-to-end process, you've got registration and pre-qual, and then the downstream integration through to the automatic dispatch, etc. I'm not looking at automating that at the moment. That is a massive, especially the downstream integration. The pre-qual stuff, we've got loads of ideas, and we really want to improve that internally and externally as the data flow increases, the volume as well. The challenge is getting the commercials through and doing it quickly. We're it's a massive organisation. We've got to do the right thing, and I'm working really hard to be quick on this. And I'm hoping that we can come out and speak to industry about it in the next couple of months. Yeah,
great. Well, they'll be ready and waiting. We're very excited to hear that.
Can I comment on the automation side? I think it's really exciting, and I'm going to I'm giving the ESO a lot of credit in this session, but I think it is due. You're in an incredibly difficult position in terms of you can't really fail, right? You can't let the system fall over. It's just not allowed. So you have to be developing these systems and changing from quite an inert, slow moving industry to having to deal with very fast moving customers and participants. There's a great presentation called The Fundamental Interconnectedness of Things that National Grid did, the ESO, on how complex it is. And they liken it to a Rubik's Cube. That as soon as you turn one side, you cause a problem somewhere else. And so it's this interconnected problem. Now, the world record for the Rubik's Cube is about 3.5 seconds. A robot, which is a combination of software and hardware, can do it in 0.6 seconds. Now, and the difference between the two is the guy has to go and have a lie down afterwards, but the robot could do that again and again and again and again. And this transition to the problems are difficult, they're complex, they're multi-layered, but by bringing in automation and allowing for like the digital progress that we've made in other industries, in vehicles, in telecommunications, none of this stuff is difficult. We landed on the moon, 50 years ago. This stuff is tricky, and I think the big challenge, as Faye's pointed out, is actually just the processes and getting that change in place. But with this backdrop of the National Grid, the ESO, are not allowed to, you can't try something and be like, oh yeah, that fell over, sorry about that. So I think it's an incredibly challenging environment for them to work, and all the time they've got little dogs like us, like Arenko, nipping at their heels, saying, we can do this, we can do that, we can do this, because we have the freedom to be on the front line of many of these technologies. So I think it's incredibly challenging, and but the way that they're engaging with industry at the moment is the way to do it.
Yeah, I would agree. From when working in data science, there's a slogan, I can't remember whose slogan it is, but fail fast and fail often. That data, people are very used to that. They try something, they fail, they try again. That is just not an option for National Grid, and we all appreciate the challenge that brings. We all, all of us on this call, we all experiencing that. We want to push hard on the automation and the data, but we are in this constrained environment in some ways. So a bit of balance of both, I think, is nice, and we'll hopefully get to that point in the future. So let's move on a little bit. I want to talk about prices in the time that we have left. I think, Nathan, maybe I'll come to you. I think maybe it'd be interesting to have a reflection on the current price in DC and how that compares to maybe FFR and EFR. And just a comment on, we saw FFR and EFR revenues, enhanced frequency response and firm frequency response, existing frequency response markets. We saw those revenues become quite saturated. What do you see? Do you see that as being an issue for DC now, maybe in the future? Where do you see the price going for DC, and is it enough for you right now? Just a few comments on the pricing, I guess.
Well, if I knew, I wouldn't be telling you. It's a $64,000 question, or pound question, rather, intimating my heritage. That's the big elephant in the room, because when we're trying to plan new projects and get investment for them, to be frank, we can't rely upon ancillary services as any part of that investment case very easily, because usually they're very expensive investments, they're long-term investments, and we've seen in very short amounts of time how the value can be eroded quite quickly. So at the moment, the value is fantastic, it would, if you could rely upon that revenue, you could build lots of batteries, but we anticipate that we won't. Certainly the tender is undersubscribed at the moment. You know, I think, is there about 300 megawatts participating, and Richard showed a table showing he would like 800 to 1600 megawatts. So clearly we're not getting to more competitive prices that are going to be more applicable for investment cases. And so that, yeah, that's really interested in everyone's opinion on this question.
Does anyone else want to come in on that?
I'd love to.
Roger, I'm sure you would.
I think it is the golden question. But and £17 is a great price. It gives double-digit returns for your investors and for the owners of these assets, and it's bringing in a lot of investment. The good news is, like I said, we dropped out recently to do some day-ahead trading. There's the new stacking capability with the BM and the work that the ESO are doing to make the balancing mechanism, bringing that up to speed for using batteries. We've got a reserve from storage trial, which is looking at using batteries and energy storage to work in the same way as gas, which will bring the volume up. And then there's the traded markets and figuring out how to use batteries in the traded markets. Now, dynamic containment, we've seen 800 megawatts up to maybe 1.5 gigawatts. The balancing mechanism is anywhere between 1 and 5, 1 and 3 gigawatts. The traded markets are an order of magnitude bigger than that. Whenever you've got competition for markets, the prices are going to stay high. The saturation will only come because when there's nowhere else to go. The cap of the price, as Richard mentioned, is the cost of the alternative action. Because the key point to this is the DC products is cheaper for National Grid. It sounds like a lot of money, but it's actually cheaper than the alternative action. And if that price comes down, it brings value to the customer. Now, just to layer on top of this, the zero carbon trajectories, electric vehicles could triple the amount of electricity on the grid. Electrification of heat could 10x, so an order of magnitude more electricity on the grid. All of these services are going to have to grow with the growth of the grid. So I think the markets are going to be there, the revenues are going to be there, but the revenues are going to be there cheaper than the alternatives. And I think it's not, even if there weren't any low carbon targets, I think you'd see that energy storage can outcompete gas in so many of these markets. We have some long duration questions to answer. That's a given, but industry will find solutions to those. So I'm pretty bullish on the prices. I think it's definitely going to come down, but there's going to be optionality. If you've got a system that can jump between markets, then these prices and these revenues for energy storage, and then the business cases, and then the investment, and then the cost of capital will come down. The technology will get better. I think it's looking positive. And that's why I'm so positive about us being able to hit this zero carbon target.
Yeah. Well, I'll just stick with your last point there, Roger. I think in the last few minutes that we have, I'd like to get all your reflections a bit on quite a tricky question, but Roger touched on it there. You know, what is the future for this market in a net zero world? I think that's a hard question to ask, but I'd like these 3 days that we have in each session, I'd really like to have some focus on looking ahead to that net zero future and what are we doing right now and how will it be similar or different? And so dynamic containment, I think we've all said today that is a bit of a snapshot for how we can make the best of the flexible assets that we have. How can we value them, reward them, and balance the system? So, Roger, just kind of continuing your point there. What do you see? Do you see DC operating in a similar way in a net zero system? Do you see it changing? You know, what do you think it will be the future for this kind of market in the next 5 or 10, maybe 15 years?
I think the post-fault service dynamic containment will and the combination with the other services, so dynamic regulation and dynamic moderation, they seem to be quite a nice set to manage the system. My question is whether they're fast enough. If we want to move to a zero carbon system that doesn't have any spinning generators, with the amount of generators on there, like still a very big system, but without spinning generators providing that inertia? Is it going to be quick enough? And the good answer to that is the industry can go quicker. So I wonder whether it'll evolve into having kind of the DS3, the Irish market, has like a scaler where you actually get rewarded for speed. The faster you are, the more payments you get. But and the good thing about that is it still allows slower assets. It allows the slower assets, so you get a diversity of systems, and diversity is like the fundamental behind any system stability. If you can encourage diversity of solutions, you don't want all batteries on the system because they'll all be responding in around the same time, and to orchestrate that you get resonance and all sorts. But if you can encourage a biodiversity across by this kind of scalar approach, that's where I'd like to see it going. But again, that's probably a 5 years out target maybe for National Grid to introduce something like that.
Yeah, I think it's great that we are looking that far ahead, and I think that's a really good point, Roger, on the diversity of the services that storage can provide, not just batteries, but all types of storage. And something I pointed out yesterday, I think we really need to be creating markets that are recognising every single bit of value that those assets can provide, and recognising that is a lot more than the thermal generation assets that we've been using previously. There's tons of stuff we can do with them. Let's recognise that value. So just some quick reflections. Nathan, did you have any thoughts on that kind of future of DC, future net zero markets?
Look, growing demand and growing markets is great for any developer. There's lots of opportunity. Grid are going to grow their procurement of DC, and they're going to implement new products like dynamic regulation, dynamic moderation, that again only grow the opportunities that we see to tell a story to our investors. I think, it's still, we would like to participate in as many markets as you can. It's a game of stacking, as Roger said. We need a diverse business case to secure investment. And so the better and earlier clarification we can get on the technical requirements of those markets, the better we're going to be in, putting those assets on the market over the next 2 to 3 years.
Yeah. Thanks, Nathan. We are a little bit short on time, but Faye, Rich, I'd like to come to you for some last reflections. Faye, any follow-ups to that particular question or anything else you want to reflect on just finally?
Thanks. I'm really looking forward to bringing in DM and DR and hearing what industry have to say. As I think Roger mentioned it as well. We are learning by doing. We don't know what to expect yet. We can do analysis and we can forecast things, but we need to hear from industry, from providers. What are you investing in? And we need to transition out the old services and bring in the new. How's that going to work? And I'm really looking forward to these conversations this year. I think it's going to be a pivotal year for that. And also, I just wanted to say thank you to the ESN for some really positive engagement and feedback. I really appreciate it. It's really great to be welcomed and to talk about this. We're really excited about it, so thank you for the opportunity.
No, we love having you, Faye. Absolutely. Rich, you get the last word. Any final comments from you?
No, I think it's been a good session. We're excited, as Faye was saying, to be engaging with people. So if anyone's got any questions or they'd like some follow-up sessions after this event, please reach out to us. We'd love to speaking to everyone around this. Helping new people get on board, working out where they're struggling, seeing if we can get them over those lines. Please do get in touch and have any further discussions with us.
Great. There have been a couple of more techie questions in the chat, I guess. So is there anywhere that people should go if they want to find out some answers to those techie questions, Rich or Faye?
Yeah, so we've got a very comprehensive suite of contractual documents for DC. We're in the middle of a consultation at the moment, so some of those may be changing over the coming weeks. But if they get in touch with commercial.operation at National Grid ESO, got a team of account managers and people that are raring to go and help people. So
cool. Well, perhaps if people keep an eye on the Hoover chat, we'll put some links up in the community to show you where to go and to direct you to some of those documents so that you can get your techie fix if that's what you need. I am running a little bit over time, so thanks so much to everyone for coming. Thanks to Faye, Rich, Roger and Nathan. I think that's been a really great chat. There's so much more we could talk about here. These things are always way too short, but thanks for your time anyway. If you like having these kinds of conversations, this is the sort of thing we love to sit and geek out about in the ESN. We have these chats regularly with Faye and Rich, with John and Kate and others at the ESO, and we're really pleased to be able to engage with them so regularly. And of course with our amazing members as well, who are always talking about this stuff. So if you want to come and chat with us about that, please do get in touch. There's always more of these conversations to be had. So yeah, that's my quick plug for membership. There's a little slide there. There's more information on the Hoover platform if you need it. So yeah, tune in for the next session at 11:30, where we're going to be talking even more about the ESO and the control room. So this is going to give us a bit of insight into how National Grid actually operates some of this stuff, which I find fascinating. It's horrendously complicated. I do not envy them their job, as we've said a few times today already. But Rob Rome, the head of National Control, will be talking to us, and we'll be interrogating him a bit on how they actually run the system at 11:30. So join us for that, and many more sessions in the afternoon, so stay tuned. And yeah, I will thank everyone, all the speakers again for being here. Thanks for our tech backup, Hannah and Rach. It's been a great session, so I will end it there. Thanks everyone for attending. Nice to see you all.
Thank you.
Thank you. Bye.
Bye.
Thanks. Bye.